rarer medium to denser happens to the refracted ray of light will move towards the normal or it will be refracted away from the normal.
Light will bend towards the normal.
Light will bend towards the normal. Yes. So whenever the rays of light will pass from rarer to the denser medium, the refracted light will always bend towards the normal. Similarly, in next case, the light is passing from the glass slab to the air. That means it is passing from the denser medium to the rarer medium. So in second case, whenever light is passing from denser medium to the rarer medium, we can see the refracted rays of light will bend away from the normal. The refracted rays of light will bend away from the normal. So this is the scenario for the refraction of the light. Whenever the light passes from one medium to another medium, the rays of light always bend. This bending of the light, this phenomenon bending of the light when it passes from one medium to another medium is regarded as a refraction of light. Refraction of light generally occurs due to difference in speed of light in different medium. The speed of the light in denser medium and speed of the light in rarer medium differs from one another. The speed of the light will be higher if the density of the medium is lesser. That means the speed of the light will be higher in the rarer medium. Similarly, the density of the light will be, the speed of the light will be lesser if the light is passing through the medium which has a higher density. So when the light is passing from rarer to the denser medium, the speed of the light will decrease. Similarly, if the light is passing from denser to the rarer medium, the speed of the light will increase. And this difference in speed of the light when it is passing from one medium to another medium, or the difference in speed of the light when it is traveling in the different medium, is the major causes of refraction of the light. It is the major cause of refraction of light. Here in the picture, you can see larger number of rays of light that is passing through the varieties of medium. You can see the line Px. Can you see the line Px in the picture? Yes or no?
Yes, ma'am.
Yes. So this line that is traveling from the air and just passing through the glass slab, this is the incident ray. This ray is known as incident ray. Similarly, here you can see another ray that gets deviated when it passes from the rarer to the denser medium. This ray is regarded as a refracted ray. And the straight line that passes from one particular point that joins the refracted ray and the incident ray, this is a normal ray. Whenever we draw the ray diagram of the refraction of light, there are three rays associated. That is refracted ray, normal ray, and incident ray. Like that in the reflection of light. We have studied about the incident ray, normal ray, and the reflected ray in reflection of light. Yes or no? Similarly, in case of refraction of light also, we have these three rays. That is the normal ray, similarly the refracted ray, and the normal ray, refracted ray, and the incident ray. So take a glass slab and draw a straight line. This straight line indicates the incident ray. Let us suppose this is AO. Okay, so the line AO that becomes incident in the glass slab that passes from the air and reaches to the glass slab, that's just the glass slab, it is the incident ray. So here I, that is incident ray, is AO. Whenever it reaches in the glass slab, the light will bend or the light will be refracted. This bended light, which is represented by OB, is the refracted ray. It is what refracted ray. On the straight that passes from, on the straight line that passes from AO and BO, making the angle between AO and BO, or making the angle between refracted ray and the incident ray, is the normal ray. Let us denote it by PQ. So normal ray is the PQ. So in each and every ray diagram that is formed to show the refraction of the light, there will be the incident ray, there will be refracted ray, and there will be normal ray. Clear? Similarly, the normal ray makes certain angle with the incident ray and certain angle with the refracted ray. When the when the ray of light is passing from rarer to the denser medium, and when it is passing from denser to rarer medium, in both of these cases, certain angle will be formed by the normal ray, the refracted ray. In some cases, the angle of incidence will be more than angle of refraction, and in some cases the angle of incidence will be lesser than the angle of refraction, and in some cases the angle of incidence and angle of refraction will be zero. Last time also we studied all three conditions, yes or no? Last time also, with the help of a video, we have studied all three conditions in which the angles will be formed. The first one is the light that is passing from the rarer medium to the denser medium. So whenever the light is passing from rarer medium to the denser medium, then there will be incident ray, normal ray, and the refracted ray. The normal ray PQ forms certain angle with the incident ray and the refracted ray, as you can see here. And as we have already studied, whenever the ray of light or the incident ray of light passes from rarer to the denser medium, the refracted rays of light always bend towards the normal. So in such case, the angle of incidence will be always more than angle of refraction. In first case, angle of incidence will always be more than angle of refraction, as refracted rays of light bend towards the normal. Refracted rays of light चाहिँ जहिले पनि normal को नजिकै हुने भएको हुनाले angle of incidence will always be higher than angle of refraction. Clear? Clear about this first? Yes. Now, the second case. In second case, the ray of light is passing denser to the rarer medium. The ray of light is passing from denser to the rarer medium. So whenever the ray of light is passing from denser to the rarer medium, in such case, the angle of incidence will always be less than angle of refraction. As we all are very, very familiar, the refracted rays of light will be bending away from the normal, because of which the angle of refraction is always greater than the angle of incidence. Clear? Clear, everyone? Clear up to here? Yes. Now, next condition that we studied, we have studied sometimes the rays of light will just directly pass from rarer to denser medium without deviation or without refracting away from the normal. Whenever the rays of light will be incident straight, yes, whenever the rays of light will be incident straight from the rarer to the denser medium or from denser to the rarer medium, it do not form any angle with the normal, or there will be the angle of incidence and angle of refraction be similar at this in such condition. In such condition, whenever the ray of light light passes through the normal light, whenever the incident ray of light passes through the normal line, the refracted rays of light also will pass through the normal. So in such cases, angle of refraction and angle of incidence that is formed by the normal ray with the refracted ray and the incident ray will be zero. That means there will be no angle formed by the normal with the refracted ray and the incident ray. So in such case, angle of incidence, angle of refraction will be similar. That means both of the angle, that is angle of incidence and angle of refraction will be zero. No angle will be formed in this particular scenario. Clear? Clear, everyone?
Yes.
Now clear? Now, next is, as we have already seen, whenever we draw the ray diagram of the reflection of light, we can see there is incident ray, there is normal ray, and there is refracted ray. So, in this scenario also, the normal ray, the refracted ray, and the incident ray all meet at a particular point. Yes, all of these meet at a particular point, which is known as point of incidence. So, in this scenario, like in law of reflection or like in reflection of light, in case of refraction of light also, the incident ray, the normal ray, and the refracted ray all meet at a particular point at the point of incidence. So these all things that we have studied summarizes the law of refraction. It summarizes the laws of refraction. Like the law of refraction, there are certain laws of reflection. There is also certain laws of refraction. The first law is just given, or you are seeing in the slide, you are seeing in the screen share itself. That is the incident ray, the normal ray, and the refracted ray all lie in the same plane at the point of incidence. That is the first law of refraction. Clear? Similarly, the second law of refraction also we have already studied. Whenever the ray of diagram, whenever a ray of light passes from rarer to the denser medium, it will bend towards normal or away from the normal. रेयरबाट डेन्सरमा जाँदा bend towards the normal or away from the normal.
Towards normal.
Towards normal.
Towards the normal.
Diagram अहिले भर्खर मैले तिमीहरूलाई पढाएँ. That is all the summarization of laws of refraction. Here you can see the diagram in which you can see the incident, you can see the refracted ray, and also you can see the normal ray. These all meet at this particular point O, that is the point of incidence. So first law of refraction tells us that the incident ray, normal ray, and the refracted ray all lie in the same plane at the point of incidence. They meet at the point of incidence. That is the first law of refraction. Similarly, the second law of refraction is also shown by the diagram, as I have already shown you. Whenever the incident ray of light passes from rarer to the denser medium, the ray of light passes from rarer to the denser medium, it will always bend towards the normal. It is what? Bend towards the normal. Similarly, whenever the ray of light passes from glass, that is denser medium, to the rarer medium, the refracted rays of light always will bend away from the normal. This is the second law of refraction. That is, when the ray of light passes from rarer to denser medium, it bends towards the normal. Similarly, when the ray of light travels from denser to rarer medium, it bends away from the normal. That is the second law of refraction. Similarly, next third law of refraction also we have already studied. The ray of light that is falling, a ray of light that passes directly through the normal, do not bend at all. That also we have already studied. Yes, the ray of light, if falls normally to the surface, through the normal, then the ray of light do not get refracted. The ray of light do not get bent away from the normal or towards the normal. So in such cases, the angle of incidence and angle of refraction will be similar. That is, both angle will be zero, which is the third law of refraction. Clear? Clear, everyone?
Ma'am,
Yeah.
ma'am, in this figure which you are sharing now, in this figure, if that rays of light will um, come straight only, that's why it becomes like that.
Your question. Can you repeat your question once again, Krishna?
Ma'am, can I tell in Nepali?
Yes, yes, Panalavan.
म्याम होइन हजुरले यो पिक्चर देखाइरहेको छ नि यो
Hmm.
पिक्चरमा चाहिँ लाइट चाहिँ माथिबाटै फल हुन्छ अनि त्यही भएर यस्तो भएको हो किनभने अरूमा त साइडबाट लाइट फल भइरहेछ नि त त्यही
Yes,
भएर
यो त स्ट्रेट लाइट चाहिँ स्ट्रेट नर्मलबाट पास हुँदाखेरि स्ट्रेट जुन नर्मल लाइन छ स्ट्रेट लाइनबाट पास भएर रेयरर टु डेन्सर अथवा डेन्सर टु रेयरमा पास हुँदाखेरि इट पासेस थ्रु द नर्मल बिकज अफ विच द लाइट डु नट बेन्ड टुवर्ड्स द नर्मल or goes away from the normal. It simply passes through the normal. So there will be no bending of the light because of which angle of incidence and angle of refraction will be similar. That is, it do not form any angle with the refracted ray and the refracted ray and the incident ray, due to which the angle of incidence and angle of refraction will be zero. Clear? Ishan?
यस म्याम
Ishan, is there any problem? You're raising your hand.
No, ma'am.
Why are you raising your hand then?
Ma'am is taking.
Okay. So here are given some of the activities to show the refraction of the light. Yes, some activities are given in your book to show the refraction of light. These activities simply tells us how the light gets refracted, how the light gets refracted. So I guess these activities, these examples, we will see through YouTube. Okay? Can we do that?